Co-teaching physical science and Algebra 1, a more authentic approach to math and science education. When I was in high school, I took a course called American Studies. It was a blended course of American government and English 12 designed in such a way that while we learned about the history of the country, we read literature from the same time frames. The class was loosely co-taught with a certified English teacher and a certified government teacher. It was set on AB scheduling and many projects overlapped both subjects. I believe the same structure would be a perfect fit for a science and math course, especially physical science with algebra in 8th grade, but the concept certainly could be combined with any math and science combination. Most obviously, the organization of math and science in this way allows for more authentic instruction. Math and science coexist naturally. The combination of the classes is a better representation of these topics in the real world. Firstly, the function of math is to express the relationships of quantities. Meanwhile, an adequate understanding of physics involves the considerable use of mathematics. It only makes sense to bring the two together. Pilot programs and trials dating back to the early 1900s show extensive benefits from the practice, including clear understanding of the math concepts, ability to recognize the math in the real world, application of the concepts to concrete situations, and knowledge of the usefulness of algebra, meaning students never needed to ask, why do we need to learn this? Furthermore, this is a truly integrative STEM initiative. The natural but not forced correlation of the two subjects and the inclusion of technology provide the most accurate 21st century learning experience. E. H. Moore in 1902 said, "Engineers tell us that in schools, algebra is taught in one watertight component, geometry in another, and physics in another, and that the student learns to appreciate, if ever, only very late the absolutely close connection between these different subjects, and then, if he credits the fraternity of teachers with knowing the closeness of the relation, he blames them most heartily for their unaccountably stupid way of teaching him." As instructors and educators, we are teaching math and science in such a compartmentalized way that the students don't even realize they correspond. Worse, according to this quote, we realized our mistake a century ago and have yet to correct it. Typical structuring of these courses today is one of differentiation and not collaboration. As an educational system, we keep perpetuating an incorrect view of academics in the real world. However, try as we might, math and science are simply not mutually exclusive. Many science teachers report that they cannot avoid using math in their lessons. One pre-service teacher even went so far as to say, "Every day is a science-math connection for me in my 8th grade physical science." Physical science may be the perfect area of collaboration as the topics are so broad. Middle school students are often less enthusiastic about traditional math and science, and the students are in the process of learning Algebra 1, which is the foundation for all upper-level maths. Benefits include benefits to content areas, teachers, and students. In addition to the real-world application, both contents stand to receive numerous benefits from the other. Firstly, the inclusion of science would make math practice more interesting and balanced in the eyes of the typical student. Intrinsic motivation to learn is often difficult to culture. However, by providing students with fascinating and interesting applications, a teacher can create an environment of learning for the sake of learning. Traditional mathematics teaching leaves many students bored. By using science experiments as practical application, math teachers can hook students and increase their learning. In much the same way, including math and teaching science concepts, can strengthen weak areas. Since the early 1900s, educators have known that teaching an abstract concept like math is most easily done by building from concrete relations. There's no better way to build this type of knowledge than by utilizing scientific inquiry. In return, inquiry just happens to be the weakest area of performance on standardized tests in science. By learning math through inquiry, students are practicing and reinforcing skills that will assist them in either subject. Teachers themselves stand to benefit the most from a collaborative two-person team approach to integrating the subjects. A single person could certainly attempt to teach the class alone, but the knowledge of pedagogy brought by two experts will provide more benefits. Science teachers can learn ways to teach math concepts from math experts. As a science teacher myself, I have been frustrated with the best ways to teach or review math concepts like equations and fractions. Most science teachers are simply not trained in these areas, and therefore we result to shortcuts and reducing difficulty in problems. With a two-person team, the math expert could step in to assist students with arithmetic misconceptions whenever reteaching needs to occur. Additionally, consistency of instruction would be inherent as the teachers would feed off each other. For example, the math teacher may use the acronym "Don't Touch Rats" to teach distance equals times time rate. The science teacher may say speed equals distance over time. These are actually two versions of the same formula. However, taught in different ways in different classrooms using different vocabulary, they seem very foreign. On the other hand, co-taught, these math and science concepts can be adjusted to correspond. Math teachers in return can benefit from science teachers in designing real-life applications. Many experts have found that students should be allowed to study concrete scenarios and examples until the abstract math concepts begin to become evident. Then the abstract statement can be applied in other situations and expressed in several forms until both the scenario and the concept are understood. After teaching math and science inclusion units, math student teachers stated that incorporating science into their lessons helped them provide real-world examples of math tools and principles. Something as simple as using Punnett squares when introducing ratios and proportions in Algebra 1 made a big difference in student understanding. While teachers of both disciplines may be apprehensive about teaching outside their content, team teaching would mean that every project, lesson, assessment, and unit would be designed by both experts. Here is an example of a biology-math collaboration. While these may sound like strictly science concepts, the following math topics were heavily featured in the plan: data collection, recording, data representation, ratios and proportions, functions, correlations of coefficients, geometry, perimeter and area, descriptive statistics, and even probability. Now this is just one example of a collaborative unit. Imagine what an algebra expert and a physical science expert could come up with. Beyond authentic learning, students will also experience other benefits. It's sad, but it's true. Many physics students do not know how to solve algebraic formulas even after passing an algebra course. They just don't find the correlation. The way these subjects are taught, the students simply do not see these applications as existing in the real world. Constructivist theory suggests that science and math should no longer be taught as an accumulation of facts and procedures, but instead taught in authentic contexts that are used to bring order and sense to the real world around us. Many teachers believe this collaboration would lead to further understanding of each subject by the utilization of the other. To them, the idea of linking math with science is intuitively obvious. Additionally, difficult topics, such as equations and the quadratic formula, would benefit from the instruction of two different areas of training and two different expertise with both teachers. While the student is working on the math, they're deepening their understanding of the physics. While they're working on the physics, they see the math concepts in action. Finally, collaboration will benefit the student's future in that emphasis can be placed on math and science and engineering to provide a better understanding of career options. By practicing math and science labs, students begin to see how these numbers exist outside of the classroom. Now, if we've known for over 100 years that math and science are best taught together, why aren't we doing that? Unfortunately, this move would come with many challenges. First of all, the curriculum would need to be extensively restructured. As they are, algebra and physical science sequences are not always compatible. They would need to be reorganized in such a way to promote the most efficient collaboration. There are many corresponding areas with which to start, including friction and constants, levers and adding algebraic numbers, density and deriving formulas, and many more. However, the pressure to succeed on SOL tests would make any school apprehensive about attempting an overhaul of existing curriculum. Another challenge is the depth of collaboration. Many schools are looking at two different approaches: integrated versus interdisciplinary. Interdisciplinary involves the preservation of those content boundaries, but common contexts are explored. This would be the least inclusive model. Integrated, it's the blending of the subjects so seamlessly it's hard to tell where science ends and math begins. Obviously, integrative would provide the most authentic instruction, but it's entirely probable that interdisciplinary would require the least amount of work to implement. Additionally, there's the issue of proper teacher training. Many teachers are apprehensive about integration because they never experienced the integration as learners themselves. This lack of experience causes them to doubt their own ability to collaborate. And finally, time constraints are possibly the most difficult roadblock. Creating all new integrative units can be extremely time-consuming, but team teaching can address this issue. However, ample time and scheduling priorities must be given to these teachers who are expected to collaborate. Despite these challenges, the benefits to the students in providing a more authentic learning experience and the benefit to our society in providing citizens that are better equipped for STEM careers is well worth the effort to adjust the ways we currently teach physical science in Algebra 1.